The first solution is shut down the machine when you're doing a backup. And this really is not a very applicable solution in today's world where machines run 24/7. The second solution is to skip the open files. And in fact, this is what we use in NT Backup because we don't have a snapshot in the Windows 2000 timeframe. So if a file is open, we just forget it. We just put a note in the log and said, we're not going to back it up. Sorry. And that doesn't seem like a very good solution either. There are specific pieces of Windows 2000 that we actually do have specialized APIs. In fact, there's about a 90-page document on how to do a backup in Windows 2000 to extract data from the services as they're running. It's very cumbersome and it's very hard to do. And because of that, we end up with less than optimal fidelity in our backups. So the last option that's here is we can create a snapshot of the data, effectively take the data and make an image of it that's set aside. This is the way a lot of the third parties do this today. But we have an advantage, since we own the operating system, that we think we can do a much better job, do this much better than what third parties can do. We also support a variety of hardware and software schemes. So let's take a look at how this works. It's a data set on a disk volume. You're writing some data. At a particular instant in time, you take a snapshot, and the data will continue writing. Now you notice the problem with this picture is that we still don't have a consistent file. In other words, the file may be half written. It's not consistent, but it's what we call crash consistent. In fact, this is exactly what happens if you pull the plug on your computer while it's running. Generally, you'll recover okay, but we really want to do a better job than that. Okay, so the concept of a snapshot, the easiest way to look at it is with a split mirrors. This is a hardware solution where essentially you have two copies of the data online all the time. And at the instant in time where we say we need a snapshot, you break the mirror and then you have an image that's sitting there. This is kind of like the EMC solution. You break off the mirror. The split is extremely fast, so you don't have much impact to the applications that are running at that point in time. It takes time to resync the mirrors. Generally, that's not too big of a problem, but it's expensive. It costs a lot of disk. The other method is called a copy on write method. So the issue at the time is we don't copy everything. You start out with sectors on the disk at the time of the snapshot. Here I'm representing it with 10 sectors. And then you take the snapshot at that point. At that instant in time, that disk is the snapshot data. So everything beyond that, you end up doing a copy on write, which means that every time you want to modify a sector, you grab the sectors and put them aside in a differential area. And those sectors become the image of what your snapshot volume is. And when you need to access that image, you simply put the sectors together so that you have one, your volume moves ahead, but each time you change a sector, you slip the data out from underneath the data and you put it into a differential area. And effectively, when you want to look at the snapshotted volume, you're looking at a combination of the old volume and the differential area whenever there's been a change. So this is the method we use for the in-the-box provider. Okay, as I mentioned before, Windows 2000 backup is difficult and cumbersome. There's a lot of different APIs. There's no consistency in the APIs. There's a lot of hard-coded rules. No forward migration plan. Every time somebody adds a different service that's running in the system, we have to go back and talk with them and find out how we're going to back up that service because their data stores are sitting there open all the time. We have no access to them. We need better fidelity, and we need ease of use for the operator as we move forward. And so Snapshot is what we're addressing here. This addresses these issues. In addition, what we've done is we've made an infrastructure wrapped around Snapshots. Snapshots on its own is just one tool in terms of doing a backup. But we've wrapped an infrastructure around it so that the backup application can get information about the service or the program that's running. And we'll go into this in quite a bit more detail as we move on, but for now we're just going to call it the infrastructure. In order to do a backup, you need a single point of time of your data. And if your backup is taking 4, 5, 6 hours or more, you don't know at the time that you're reading this data to the time you get to here if you're still consistent from the end to the beginning of your backup. We solve that problem. And we need to make this extensible so that it works everywhere from the desktop all the way up to a SAN solution. Okay, so this sounds like a really complicated goals, but actually it turns out to be pretty simple, and we based it upon the technology that Windows 2000 has, the box, XML for communicating data between backup applications and the running applications, and COM interfaces. So it's simple, simplifies the approach for the backup application and for the running application. And in fact, we've been working on this for several years. All right, so now we're going to get kind of down to the nuts and bolts about what we're doing here to make this work. This is the basic block diagram of the snapshot system in Whistler. We have a requester, which is a backup application. We have the IVSS interface, which is the snapshot interface. We have writers and providers. So let me kind of introduce what these are. A writer is a little piece of code that runs in an application or service. And it's the coordinating code that coordinates with the backup application. Tells it where the files are, tells it where its components are, et cetera, et cetera. We'll get into it later. Providers provide the snapshot mechanism for either a hardware or software solution. So if you have an EMC solution, we obviously want to take advantage of that. So we want to put something into the box that they can snap into, that once a backup application and all the other applications understand how this works, every hardware or software provider that wants to snap into this will work fine. So the providers, you can think of from hardware, you can think of this as the EMC. They're writing a driver for their splitting mirrors, etc. And for the writers, every application has to include this little bit of code that it takes to coordinate with the backup. Once you have those done, the infrastructure is in place. Okay, so the first thing, as we walk through the process here, the first thing that the requester does is he just initializes the snapshot interface. And at that point, he's allowed to enumerate what writers exist on the box, because not every application will have a writer, and what providers he has available to him. So he enumerates the writers, and he might say, well, I've got an Active Directory writer, and I got a cert server writer, and et cetera, et cetera. He takes a look at those, and the writers provide metadata. It's an XML document that's generated by the writers that the backup application can look at. And the XML document contains, at a very high level, it tells it where the data is being stored on the disk, where's the components, where's the files, which files are to be included in this backup, and which files are not to be included in this backup. So he processes the metadata, and from this, he can aggregate a list of what needs to be backed up. Perhaps the operator hasn't decided to back up everything, so he can say, well, I need to back up my C colon and my D colon in these specific directories, these locations. So he's already got a lot of information about the services and the applications that are running at this point. Once he does that, he notifies the writers that a snapshot is going to commence. So he tells the snapshot interface, I'm going to do a snapshot now, so get ready. And this is called a prepare to freeze stage. During this stage, there is unlimited time for the writers to do whatever they deem necessary to get ready for a backup to happen. And maybe this, in some cases, we have simple cases where a writer will simply make a copy of his database and put it down into a repair directory or put it into a backup directory and set it aside there and say, okay, I'm done. It isn't really the recommended method, because suddenly when you get a prepare to freeze, you've got all sorts of disk activity. But nevertheless, that's a very simplistic case of getting ready for the freeze to happen. At that point, everybody acknowledges that they've prepared to freeze, and we're ready to move on. And now we get into the freeze phase. The freeze phase is very time critical. That's why we gave you a prepare to freeze. When we hit this stage, it's time to do it now, because we're holding up all applications. At this phase, the writers will stop all writes to the disk so that we don't have the problem of the writes being torn in the middle. They'll stop all writes to the disk, and the providers, once the writers say, okay, I'm frozen, which usually happens like within 10 seconds, so everything's going to be frozen for that period of time on your screen. You're not going to get any interaction with the disk. Then the writers at that point say, okay, we're ready. At that point, we flush all the data, we flush the buffers to the disk, and we start the copy on write, which is that's the software. At that point, you would split your mirrors, do your software solution, whatever it is. So we've created another set of disks, an apparent second set of disks, and that's what you see over there next to the requester. We've generated a snapshotted volume at that instant in time for the requester to use. Okay? Following that, I got to ask the writers, were we okay? Did that work? Because sometimes, for instance, if you're copying the terabyte file through your WebDAV server and it's got to get upgraded, the writers will say, I couldn't do it. It was just too hard. So the writers all have an opportunity to stand up and say, I failed. And in that case, you'd have to go try again a second time. So we find out if the writers have succeeded. And in fact, writers may fail and you won't care. If I'm just backing up Active Directory and I didn't get that file copied, that's good enough. All I want is the files that aren't torn. So I'll go ahead and take it at that point. Then the requester, the backup application, has all day long with its own private set of disks to go ahead and do its backup. We know because the writers stopped all activity that the backup will be consistent. We've converted everything, we've leveled everything to flat files. If you had a SQL database, the writer would say, okay, we're good, we're done. Take it. You now have a copy of the SQL database. Same thing with Exchange. The writers say, we're in good shape. Take it away, and you have all day long to sit there and copy your data to the tape without impacting your server. The only impact you'll have is that the longer you take, the more your differential area grows. So you got to have enough disk space to accomplish this. After the backup is done, there's an opportunity to close the loop with the writers. So there's a backup components document that's generated after the writer metadata is produced and given to the requester. The backup components document says, initially, it gives it to the writer and says, this is what I'm intending to back up. At that point, it's writable. The writers can annotate that with whatever information. They can add information to that document. But at this point afterwards, once we've indicated success, that data is on the tape. It's already moved off to media. And so at that point, it's a read-only document to the writers. So the writers get this and say, okay, this is what was successfully backed up. And at that point, they may want to use it to truncate logs if it's a database, or what other final processing they have to mark things as being backed up. We know that we've closed the loop and that the backup has been completely successful. And there you have it. The backup is complete. So this is the snapshot. Now you see that it's not just the snapshot that we have in the Whistler time frame. It's a whole infrastructure that wraps around the snapshot that allows the applications that are running to communicate with the backup application. The communication happens, the backup is done, we've closed the loop. In addition, the backup application has all sorts of information, icons, files, components that could be presented to the user prior to doing the backup. So what we've done is we've taken the concept of a snapshot and we've wrapped a complete infrastructure around it that allows you to use it to do backups with a much greater fidelity than we've ever been able to do in the past. And since it's part of the operating system, we can do a good job at it. We can really do it right. We know how to flush the buffers, and we know how to, sync the disk. And finally, the last step, sorry, I guess I jumped the gun a little bit. The last step is to delete the snapshot. We're done. We finished the backup. Destroy the snapshot. And resync the disks if it's a set, or destroy your diff area. Okay, so that's the high-level view. What I'd like to do now is to dive in a little bit into the detail of the metadata, the snapshot and the metadata, starting with what we're adding for a backup. It's a way for the application and service to describe its data, to describe what's being backed up and the coordination between a backup application and the services and applications that are running. That's what we're adding to the snapshot. There's two kinds of documents. The writer metadata document, which is XML, which is dropped into memory by the writer, and it describes what it is that the writer needs in order to back up the application that it's responsible for. The second one is the backup components document. It's initially created by the backup application. It's sent to the writers so that they know what the backup is backing up. They have an opportunity to annotate it at that point. And then it's finally, after the backup, it's sent back to the writers to tell it what was successfully backed up. So something that's missing in the backups today is, once the backup is done, it's the operator who's told, hey, we didn't get a file, or we crashed, there was a problem. Now we know that the writer is aware of the fact that something didn't get backed up completely, and he has the opportunity to do something about it. These documents are based on a concept called components. It's a very important concept to the backup, because if you take a file-by-file backup, it doesn't necessarily capture what you're wanting to do, because, for instance, databases are not just database. They can be spanning multiple volumes. They can have log files associated with it. So a component is something that needs to be backed up together as a unit. And if you're not successful with the entire component, you're not successful with the component at all, which is a concept that just hasn't existed up to this point. So it's important to understand what the concept is. So the component description is a name. We get the instance, the database, for instance, in a SQL server, the physical files, the icon, and a caption that can be presented to the operator. So included in this, in addition to this, we have the files to be backed up and the files not to be backed up. Here again today, we do have a concept of files not to be backed up, but unfortunately it's maintained from the backup standpoint. And so we catch a few. We know that we're not going to back up temporary internet files, and we're not going to back up certain specific items. But this is an opportunity for the person who owns the application or the service to think about what's going to happen at backup time, which is really where the responsibility lies. So they can list the files that they don't want excluded, that they want excluded from a backup, temporary files or cache files or things that are going to be rebuilt. And so we'll be able to get a much greater fidelity in terms of what's being backed up. And also there's an opportunity to say how to restore the data. We have a lot of different methods of restoring the data. Perhaps you just want to put the data back. But maybe that's not right. Maybe you need to put the data aside somewhere and then let the application pick it up. So we have the ability to restore to an alternate location and then send a notification to the service that, okay, we finished the backup and we shoved the data off in this corner for you to rebuild. So here again, we're building the whole infrastructure so that regardless of how complex your application or service is, you'll have the ability to coordinate during the backup. The backup component documents consist of the writer name and the logical name of the components. Here again, for the concept of the database, you have a component which consists of the database itself and perhaps some log files, so you can roll forward, roll back. The information of what was backed up is listed in the backup components document, so there's good coordination between the two. So it's available to the writer at the prepare to backup phase. The writer can associate additional data with a component. He can annotate this at that. Prior to the backup, he can annotate it with things. He's going to get this back at restore time, so he can annotate the document with specific items. Feedback, whether the component was successfully backed up, so that the writer can determine whether his backup was successful or not, as opposed to an operator seeing something in a log that says, oh, by the way, we didn't back up this file, which is meaningless to an operator. Okay, so this information is saved on the tape and is available at restore time. Essentially, it's the same, the writer metadata and the backup components document, so that we have a completely closed loop prior to and after the backup. At restore time, we know exactly what happened and exactly where we're headed with the backup. Some of the restore methods that we have is to restore files if they don't exist, restore them if they can be replaced, and this goes on a component level. If you can't replace all the files, don't replace any. Restore them to an alternate location. We have the ability to stop a service and restore it, and then restart a service and replace it upon reboot. We have the ability to replace the file only after a reboot happens, at the time a reboot happens. Okay, a little more detail on the backup components document. Contains information used. This is a little bit of a recap. You can restore to an alternate location. It's an all or nothing affair. And then the applications have the ability to do additional work based upon the backup components document. Okay, so when are we going to do this? Whistler, this is really a very big feature, and it's requiring a lot of coordination with the outside world, with the independent software vendors that create backup software. I work with all of them, all the major vendors out there. Whistler is a transition. In the Whistler time frame, we're not breaking backup applications. We're going to keep all the APIs intact. All the new APIs are going to be available, so you can do a snapshot. If we have an ISV who wants to use the snapshot technology, which basically, by the way, is all of them, they're very excited about this, they may do so. But we're not breaking any apps. And the real advantage here is that in Windows 2000, we discovered there were great deployment blockers because there are no backup apps ready in the industry. So, for instance, Boeing said, until Veritas has my backup application, I'm not upgrading to Windows 2000. So we're not going to get that in our way again this time. This infrastructure, the snapshot infrastructure, will continue to evolve. We're looking at this as a V1 release. We think we've put enough in there so that the backup vendors can actually do their job. But we're going to continue to involve it post-Whistler, and I think you're going to see a lot of new features and changing features based upon the snapshot technology in the post-Whistler timeframe. Things like RIS, the ability to get the data out so you can do remote installs, and there's all sorts of persistent snapshots for backing up on a sector-by-sector basis. The rollback, when you have drivers, something equivalent to the Millennium, the system recovery. So you do an install, and you discover you installed a driver that completely screwed your system. The ability to roll back. We're going to be working with a lot of different organizations so that they can use the snapshot technology. And writers. Now, as you could probably figure this out by now, that writers have to be there for this thing to work. If a writer doesn't exist, you get a crash consistent approach, which is the same as pulling the plug. So, you know, if you pull a plug, generally Windows 2000 is going to come back. It does a pretty good job on recovery. But unless you have a writer that's telling the service of the application to throttle itself back during the snapshot period of time, you have the possibility of having problems. So we're evangelizing writers in Microsoft now to get writers included. And in fact, we already have a lot of the system state writers put together. We've done some what we call a shim writer, a temporary writer, so that we can move forward without all the actual writers. But our real goal is to finally get incremental and differential support for SANs so that we can really move the snapshot into where it needs to go, into the real big storage systems. Okay, We're providing the common API for the coordinator. We're helping Microsoft applications incorporate riders. This is what I basically just told you. We have a limited provider in the box. Kind of the way Microsoft works is we made the rider, the copy on write rider, which will work with all disks. It may not have all the features that you want to have, but we're anticipating third parties are going to pop in here and come up with more complex riders as the market moves on. And we're already working with hardware providers, people like HP, Hitachi, EMC, so that there are providers ready at the time that Whistler hits the street. The ISVs, incidentally, are very pleased with this because right now backup is such a hard problem to solve. So we chose the snapshot as our general paradigms. We've wrapped around a low-end story using the drivers, the copy on write drivers that we have. We have high-end stories, people like EMC, snapping in their providers. It's going to be a lot less programming effort to do the backup. Unfortunately, some of the programming effort is going to shift to the writers, but ultimately that's really where that effort needs to be when you want to understand how to do the backup. And it will be very useful if anybody here is involved with the serverless backup, the NDMP protocols, and Celestra, if you're familiar with Legato. It'll be really useful as a basis for supporting this type of backup. Okay, key deliverables, the file system synchronization, the thaw APIs, the trained application. This is the writer pieces. We're still better even if an application doesn't have a writer because we believe the crash consistency is actually better than, in some cases, than what we're doing today. The other thing is, one thing that we don't support at all today is backup at a point in time. When we're doing backups today, some third parties do support this, but when we do backups today, we just start at the file system and start working through it. And so a point-in-time backup is really a much higher fidelity. Ultimately, what you guys are going to see is you'll see ISVs implement this, and you'll get much higher fidelity in the backups themselves, in the restore capability for restoring individual components and pieces. Have a much greater fidelity for that. And in addition, the backups aren't going to be, they'll still be time-consuming, but you won't be holding up your server, holding up your storage system while the backups are happening. Okay, so here's a picture of basically how it's implemented. I don't want to go into great detail here, but the kernel pieces, where the coordinator sits up in user mode, the kernel mode, Babbage is the snapshot provider, and then the disk volumes at the driver level. The in-the-box provider, it provides only a read-only snapshot. At this point, it was much easier to do a read-only snapshot, and that's what's perceived to be what's necessary in this case for backup. Snapshots disappear upon reboot. In other words, if you have a failure during the backup session, you're going to have to restart the whole thing. And this says only one snapshot active at a time. A snapshot can span multiple volumes. In other words, if I have to snapshot my C, D, and E, you could snapshot all three of those, but we only allow one snapshot at a time. In other words, if you have two backup applications running on your box at the same time, and you want to snapshot C and D with one, and D and E on another, we don't support that. A volume can only have one snapshot active on it at one time. But ISVs can extend this. They can do more capable snapshot providers if they like it. Okay, I'm going to try to do a demonstration of snapshots now. And let me see if I can do this. Okay, so I have some IDW tools that I can use here. So I'm going to create a snapshot of C:, and it looks like that worked. And then I want to take this device name. I'm going to surface a volume letter. Didn't mean to do that twice. So I'm going to surface a volume letter for it, and I should see X here. Now I have a snapshot. That process I did there when I did VS Create, that created the snapshot. But the snapshots don't automatically surface the volume levers, so the DOS-DEV, I now surfaced X. So now I have a snapshot of C colon that's X, okay? X is read-only, but if I go to C colon now, and I say, let me just, I hate this keyboard, it's awful. I'm sorry? I could do that. And I could do this as a file, save to C:/test. And if I could type, I'm sorry that I get nervous during demonstrations, but I really do, so you have to bear with me here. So now if I just do, there you can see test.txt. Now if I go over to the X colon here and do a dir, you'll see that test.txt doesn't exist. So essentially I can go ahead and work on C, the machine can work on C, and I've surfaced a drive letter X that goes ahead and made the snapshot. So if I go back to C, and what the heck? No. Now if I go to X, it's not there. I just deleted the snapshot X. So okay, it's kind of hard to demo a component that's so deeply built into the system, but essentially that was the concept. We are using this. NT Backup will support snapshots. It does support snapshots today, and it will in the Whistler timeframe. We are using it. It works well. Backup kind of has a minimum implementation of the writer metadata document, but it's enough to understand what the files are to include and what the files are to not to include. We opted not to do a great deal more work with NT Backup because we don't anticipate that it'll be used in an enterprise environment. I'm working with all of the ISVs. They know about it, they're excited about it, and most of them have already started implementing an application with backup in it. Yeah, go ahead. Exchange has already started looking at it. SQL already has one in a simple case. The simple case is no roll forward, roll back. It's just the monolithic backup. And it also works with MSDE, which is important to us because there's MSDE embedded things in Whistler. So in fact, both of those have already started. Exchange doesn't have anything working. They're looking at, we have an SDK that we've produced and some white papers, and they're looking at it. They have promised to have a writer out at roughly the same time Whistler hits the street, but I'm not sure if people will use it because it's just going to become available at that point. I really think that'll probably take another year or year and a half before you actually see people using a writer to backup Exchange. However, it will be there. You don't have to use the infrastructure. It can just sit there. You can still use the old ways, but it'll be there. Yes. Yes. Yeah, believe me, I talk with Mark Wistrom very frequently, and he has a lot of pressure on him to get this done. In fact, there are third parties, hardware vendors who are coming in and saying, you have to do this. Right now, companies like EMC that split mirrors, they just split it. They just say, this is it. I don't see any activity in the system now, let's split. And there's nothing guaranteed to be consistent. In fact, I'm nervous that one of these days somebody's going to come up with a torn write and they're going to lose Active Directory or an Exchange database, and it'll be a mess. Yeah, there are writers there. There are actually in the order of 5. We have a shim writer, which takes care of Active Directory and cert server. We have there's an IIS writer that's in Whistler today. Yes, there are writers in there, part of the operating system with the installation. It all happens, I mean, you would never know it because it's the coordination is all kind of below the covers. No, not with the snapshot infrastructure. However, if you had an application where that became something that you wanted, like a rollback, it certainly could be implemented. No, that's not part of the backup infrastructure. That's not really a common backup thing to do. And we've really targeted, we think the biggest first market for this is going to be the backup industry. And so there's lots and lots of ideas about how snapshots are going to be used, but our first target is backup. Yes? Okay, the freeze period is typically 10 to 15 seconds. And during that time, the computer will really be suspended. However, in an application like SQL Server, where the computer is really dedicated to the server, I would anticipate the actual freeze period being less because there's so much backup infrastructure built into SQL. SQL already uses snapshots. It's their own little homebrew snapshot. But they already use a snapshot, which allows them to just simply annotate the log. I don't know a lot about databases, so you have to excuse me, but they essentially annotate their log as this is a point in which we're freezing, and then they create new logs from that point on, and they can roll forward, roll back. So they're not doing a lot of copying of data or moving databases around. They just simply say, finish the transaction that you're on and stop. Let the freeze occur, and then pick up and continue. And so it will be as much as 60 seconds. I think the timeouts are set somewhere around the 60 to 90 second time frame. You will have the machine pausing, and nothing pauses except access to the disk, and we've made special considerations for the page file and things like that. The machine will freeze for that period of time during the freeze while the disk buffers are being flushed, and we've created our diff area. But that's only with our writer, with our provider. If you used EMC, that freeze time's much quicker because it's a hardware freeze. At that point, you're consistent, you just break split the plex. Yeah, it's a very good question, and it all depends upon how the provider implements. But I would presume that a company like EMC that charges, like way big bucks for theirs will do a good job. Yes. No, the freeze will never be that long. We hope that the freeze won't be that long. Generally speaking, it will go ahead and continue its write. The file system buffers, we flush the buffers at that point, but the file system buffer, we haven't seen any issues with this, that the application just simply, wait for the disk to be ready, and then once the disk is ready, they continue their writing. Yeah. Generally speaking, a backup application won't do that, because if he does that, he risks the opportunity for a user to actually go in there and try to muck around with it. Now, it is a read-only, so nobody's going to write to it, but generally a backup application would access it, via // global device, and never surface a drive letter. That's why we intentionally didn't surface a drive letter. I had to do that with a DOS-dev command. Yeah. We create a diff area, and essentially there is no physical store associated with that, with the snapshotted volume. The physical store is a combination between the diff area and the initial volume. You cannot associate that with a volume on a disk. That snapshot, it's being managed. It essentially looks at the old volume until it hits a sector that's been changed, and then it goes to the diff area and picks that up as you're reading it. Yes. It's not physically placed. The physical, essentially, there's two areas where the data is physically placed. That's the initial volume, which is there and continues to roll forward, and then the diff area, which is as it rolls forward, you begin to build the diff area. So you have to have enough space in your volume to hold all your differentials. The diff area is on it's in a file on the same volume, or it's on a different volume. That's what you're asking. Yes. Well, I'm not sure I can answer your question. I don't know enough of the details. I know we flush the buffers. I believe that any hardware cache has to be able to support a flush command from an ioctl to flush the buffers. All I know is it works. So we've used this, we've had this up and functional for 6 months. We've been testing it daily using NT backup. We've had lots of problems, but it's working pretty good now. And in fact, I could pull up a backup here and it would say snapshotting the file system. And then after that finishes up, off it goes and does the backup. And we're getting very good fidelity in our backups. Okay. Yeah, okay. Last question. No prerequisites. It works on any recognized file system. You have to have enough space on your file system for the diff area. If it's a RAID 5 set, the RAID 5 set to NT simply just looks like a hardware RAID set you're talking about. A hardware RAID set to NT looks like a volume, and it's a volume snapshot. It will snapshot. You have to have enough space on your disk to contain the diff area. We don't copy the data. We don't make a clone of it. Okay, in the initial slides, when you're looking at the volume that's a snapshot volume, you're looking at the original data for everything except the sectors have changed. And if you recognize that, oh, here's a sector that's changed since the snapshot occurred, you go to the diff area and you pull the old sector from there. So you're really aggregating the two stores to come up with your snapshot data. Okay, I'm going to have to turn this over to Ed, but there'll be more time for questions. I'll stay here all night if you have questions after that, so hold on to it, and I'll let Ed go ahead with his stuff. There you go.
Well, snapshots are just one of the things that we've done in the file system in Whistler. We've made a lot of improvements. We started out with FAT. It was good for a while. Apparently, FAT is starting to wear a little bit thin. So we have NTFS. In NTFS, we've made a bunch of improvements. This is just for reference only. I won't go through it. One of the new file systems that we have added in Whistler is UDF 2.01. I'll explain why this is important later. So what exactly is UDF? Basically, if it's on a shiny disk, it's most likely UDF. It replaces CDFS. Basically your old legacy CDs, it's uses CDFS. UDF is read-only in Whistler. We are looking at making it read-write in Blackcomb, but as you guys know, that's going to be a little bit later. And basically, a bunch of companies have already announced that they're going to make DVD RAM-based camcorders, DVD RAM-based DVD players, and UDF 2.01 will allow us to actually read those from the camcorders in Whistler. We also have DVD RAM read-write support, but using the FAT32 file system. And that's basically all I need to say about that. This defrag has been improved. It's an excellent way to gain performance. A lot of people still don't run it, especially in the consumer space. We now defragment the MFT, which gets you a little bit of speed. We had some GUI enhancements. We also made it faster. We can defrag a numerous amount of cluster sizes. Before, if it was over 4K, we couldn't do it. We can defrag all parts of a stream. If you had a file system that had a lot of streams on it, we really couldn't defrag it very well. And it's a lot faster. But most importantly, one thing that we've done with just defrag is added command line support. We feel your pain. A bunch of people have commented on, okay, I have Windows 2000, but I can't do anything from the command line. We realize that command line is important to a lot of your customers, and we're doing whatever we can to add command line support. So defrag, basically, defrag.exe, C:, or D:, whatever. Another thing that we've done is added volume manager task. How many of you guys have heard of diskpart? I'm just kind of curious. A lot of you have heard of diskpart. And then how about fsutil? There is not CD support for diskpart as far as I know. But it's part of it, but diskpart is in its infancy right now. We are looking at adding a lot of features to it. Right now, we're just making sure that it works on stripe set and RAIDs and whatnot. We want to make sure that it works on the basic functionality before we add a bunch of other ones. And basically, diskpart, you can script it via redirection and, of course, fsutil. And I'll go into a little bit more of what those are and what they can do. Diskpart allows command line support for basically a lot of your volume manager tasks. You can create basic and dynamic disks. You can convert to basic or dynamic. You can create stripe sets, do your mount points, you can assign drive letters, extend volumes, and whatnot. You also have the ability to do things to your system volume, so you got to be careful with diskpart. You can destroy your drive. And let me just go ahead and show you a little bit of what diskpart can do. Oops. As Steve, my typing does kind of decrease when I'm in front of a bunch of people. Let's go ahead and open up diskpart. As you guys can notice, diskpart isn't a full command line where you can just type in diskpart, disk1, blah, blah, blah. It does actually have a little bit of a shell. You can still script it using redirection, which I'll show you in a little bit. But let's go ahead and create a stripe set. That's something that, on the volume manager, it just kind of takes a little bit of time, but with diskpart, it makes it quite a bit easier. First thing we need to do in order to create a stripe set in Whistler is to convert the disk to dynamic. So we need to select the disks, and I'll go ahead and show you what disks we have right now. Disk 0 is our system disk, and there's 2 external SCSI drives connected to my system. I'll go ahead and select my first disk and convert it to dynamic. It just takes a couple seconds. And I also want to include disk 2 in my stripe set, so I need to convert that to dynamic as well. So I just converted 2 disks to dynamic via the command line. Really easy to do. So I'm going to go ahead and create my volume. I'm going to call it stripe, and I'm going to include disks 1 and 2. I've just created a stripe set from the command lines. Again, you can also do mount points and drive letters from diskpart. I just created the stripe set. Right now it doesn't have a drive letter. I like H. Oops, I have to tell it that's the letter H. So I'm going to assign letter H, and now my stripe set is H. Of course, it doesn't format it for me. That's one thing that diskpart doesn't do is format. You can still format from the command line just as you would before. So I'm going to go ahead and convert it to NTFS because it's a preferred file system, and I'll go ahead and do it quickly. I'm going to go over to my computer. Drive H is there. And since it's formatting, I can't get the details at the moment. There we go. Let's refresh, and drive H is created. So my 2 disks and the stripe set, I just did it by command line. Now, what about scripting? Well, we do have scripting support using diskpart. Let me go ahead and delete the stripe set. Again, it's really easy to do using diskpart. I can list my volumes. My stripe set is now volume 0, so all I have to do is select it. Now, one thing about diskpart is that you have to select the disks that you're going to be using. You just can't say delete volume 0. You actually have to select the volume and then delete the volume. Now, there's one little thing in diskpart right now. It's going to be fixed before it ships. It decides to create a partition for me. It thinks it's doing me a favor because, okay, I just wipe the disk. You probably want a partition on it. That isn't necessarily the case. So I'm going to go ahead and delete the residual partition. See, there's a partition. We'll go ahead and select it and delete it. And as you can tell, it just deleted the partition. I'm going to go ahead and do that again with disk 2. Select partition 1, delete it. And if I can spell partition, okay, both of them are gone. So again, through the command line, I can edit my disks. I can create the disks, delete them, configure them all through diskpart. Now this is how we do it from a script, because we actually showed this to a bunch of people, and they said, okay, this little shell doesn't provide me the scripting interface that I want. So we realized that, okay, it isn't a typical command line program where you can just say, do this, and it does it. But using redirection, you can create a simple text file to tell it what you want to do. This is basically what I did in the command line. I just said create volume stripe, include disk 1 and 2, assign it a drive letter, and then exit. And then I also created a batch file that calls diskpart. That's how you bring in your text file, and then go ahead and format it afterwards. Now, one thing that we have to do, I didn't include in my script to convert it to dynamic. So, as you know, in Whistler, the only way to create stripe sets is to have it be dynamic. In Windows 2000 and NT4, you could have stripe sets on basic disks, but we really want to urge you to do that on dynamic disks, so we made it so you only can do it on dynamic disks. So we're going to go ahead and select disk 1, convert it to dynamic. Again, it's that easy to do. Convert disk 2 to dynamic. And when we list the disks, as you can tell by the asterisk, both of them are now dynamic disks. And, oops, should have stayed in command line. Using my script stripe, This is a quick format. It takes a little bit though. But now, one thing that this will allow you to do though, with your customers, obviously you're going to be deploying servers, and now you can pre-create your scripts to allow them to set up their stripe sets, to create mirrors, do everything that they need to do just with a click of a button. And just to verify that that did work, we'll go ahead and go to my computer, and there is H at 8 gig capacity. This part is on the CD. It ships with Whistler. Before it was going to be a res kit feature. Yes, go ahead. As far as I know right now, there is not a plan to make it a COM object. If you plan to script it using VB script, you can still call a shell command and run it that way. So, yeah, I mean, again, we're trying to get the basic functionality first before we make it all nice and fancy. Just because, it is one of the major requests from clients is that we need command line support. So we'll make a command line first, and then we'll look about making it allow you to connect to it using objects later. Is there any questions before I go on about this part? All right. Basically, it's on the CD. Like I said, we're going to make it part of a res kit, but we decided it was important enough to actually ship it with the product. FSUtil is another thing that we decided to create to give you command line support for a lot of other file system issues. It allows you to control file system behavior, and what that means is, like, let's say your quota notification rate, you can control that using FSUtil, manage the dirty bit on a disk. You can manage files, like find by SID, find short name, edit the short name. You can manage your quota. You can set quota on users using the Whistler quota management system. You can access a change journal by looking at dates and times of when the things changed on your volume. Does everybody know what the change journal is before I see a lot of heads going no. The change journal, what the change journal is in NTFS, it's there in Windows 2000 now. The change journal allows you to find out which files have changed in the file system. So basically, you boot up your system, and the change journal is pretty much empty because nothing's changed. Well, over the course of time, certain files get deleted, edited, opened. It doesn't track opens, but if you delete a file, you edit a file, you want to know that the file's changed. So you can use the change journal to go through and find out which files have changed in the past, X amount of time. It tracks that it has changes, not the nature of the changes. I hope that's a good enough explanation of what the change journal is. And this will allow you to go to the actual file and say, show me the change journal entry for this file, and they'll say, okay, it was last edited at this time. This is the ID of the file, et cetera, et cetera. And also with FSUtil, you can extend a volume. And let me go ahead and show you FSUtil. You can even cut a tin can with it. It does everything you want it to do. Well, let me go ahead and create a volume besides the stripe set that's already taken up the full size of my disk. So again, it's volume 0. We're going to select volume 0, delete the volume. Now my stripe set's gone. We're going to go ahead and select disk 1. And we're going to delete that pesky partition that it created for me. Oops. Pardon my typing. Going to select partition 1. Delete the partition. Then we're going to list the partition just to verify that it is gone. We're going to go ahead and, just to verify that I have focus on this disk, we're going to select it. We're going to tell it to create a partition, make it a primary partition, and make it just 100 megabytes. Okay, and it already assigned a drive letter for it. So we're going to go ahead and format it so we can work with it. Again, we're going to make it NTFS because I love NTFS. Okay, so what we have here is a 100 meg drive. Now, obviously, you would have, like, let's say you had 2 partitions. You deleted the second partition, you don't need it anymore. So now you have this 100 meg partition. What are you going to do with it? It has files that you need. Well, one thing that we'd like you to do is extend it. Rather than delete it, move all your files off. Now you can go ahead and extend it by using fsutil. Now, fsutil allows you to do it with one command line, unlike this part that you have to go into the little shell that it has. I'm telling fsutil that I want to do a volume function. The function that I want to do is extend. And I want to extend volume E. And let's just increase it by 100 megs. Done. So now I just go over here. It's now 196 megabytes. It was that quick. So now when you're going into your service scenarios, they delete a partition. You can now make use of that extra disk space. As you can tell, it only takes a few seconds. Regardless if you do 100 megs or a gig, it's just that quick. And again, we'll verify that it actually did do it. And there it is, 1.16 gigabytes. So fsutil is something that you guys can use in your client sites just to really, really get some ease of administration. We have looked about, the question is, can you shrink a partition as well? The answer is no. We've looked at doing it. It's really easy to extend a partition because there's nothing there, so you just increase it. In order to shrink the partition, we have to worry about the data and do some sort of fiddling with the bits. We're taking it into consideration. We're looking at possibly doing it in Blackcomb, but I can't say we're leaning one way or the other. So that's the answer for that. Another thing that we're doing in Whistler is allowing you to do CDR and CDRW mastering in the box. I don't know if you guys have played with it at all yet, but all you have to do is have a supported CDR drive. And supported CDR drive just means that it's what's it called? It's version 2 of the CD-ROM thing. I just can't remember right now. But basically, any drive made in the last 5 years will be CDR compliant. It's available on all of the platforms, all the way down from personal to data center, and basically all you have to do is just drag your files down to the CDR, and you just click burn, and it's done. We added support for read-only NTFS. This basically allows you to mount snapshots, as we saw in Steve's demo, but it also allows you to have the ability to mount volumes containing applications or web files that, this is just another step of security. If you mount a volume using read-only NTFS, nobody can edit it, so that's kind of a nice little thing. Is it possible to change the partition to read-only on the fly? The answer is no. You actually have to dismount it and then remount it as read-only. And I think Steve verifies that. We've made a lot of check disk improvements as well. Check disk is still something that you see a lot in your customer sites, I'm sure. There's still a low chance that check disk will be invoked, less than 1%. If you, in your test labs, go ahead and just take any machine, just take your machine, as long as it has NTFS, pull the plug on it, there's a 1 in 400 chance that machine will run check disk. A lot of the improvements that we've done in Whistler are performance related. As you can tell by the chart, in NT4, basically a heavily fragmented system with 2 million files, 49 hours. With Whistler, it's basically 0.38 hours. So basically we're talking about 20 minutes compared to 49 hours in NT4. Win2K is still a significant increase from NT4, but not quite as fast as Whistler. Just wanted to say, in all test cases, you won't see this kind of improvement. The improvement that we see is anywhere, compared to Windows 2000, is from twice as fast to 10 times as fast, depending on the scenario. Now, obviously, if you hardly have anything on the disk, you're only going to notice a little bit of difference. Where you notice the main difference is on a large server with lots of files. What we've done is we've eliminated a few passes. We noticed that we were doing a pass to enumerate data, to enumerate the directories, and we decided to actually combine some of the passes to make it a little bit faster. So check disk is still works as good, it's just faster. So to sum it up, basically command line tools have been added because we know that it's just something that you guys need out in the field. We've added support for DVD RAM, also support for the UDF 2.01, especially when you get those camcorders that are writing it straight to DVD RAM. That's going to become important in the future. Defrag's faster, check disk is faster. You can burn CDs right out of the box, and it's easier to manage, and you also have performance improvements. So at this time, I'd like to open it up for questions, whether or not it is a local file system issue or a snapshot issue. The question was, are we adding support for groups in Whistler? And quota groups. And the answer is no. In quotas in Whistler will pretty much stay the same. Now in quotas you'll be charged for MFT usage. There's a little couple of performance increases. But in Blackcomb, we decided to significantly change the quota management system. If you're interested in what we're doing in Blackcomb for quota management, come see me right after the talk. Yes? Yes, NTFS was changed to support snapshots. It's done on the file system level. That's why it's so quick. Any other questions?